Hello everyone. Um, Today we're doing SAT math, problem solving, and data analysis, and more specifically we're looking at the subsection probability and conditional probability, and also as always we're looking at 5 difficult problems. So let's start with our first question. It says human blood can be classified into 4 common types: A, B, AB, and O. It is also categorized by the presence or absence of the rhesus factor. The table above shows the distribution of blood type and rhesus factor for a group of people. If one of the people whose rhesus negative is chosen at random, the probability that the person has the blood type B is 1 over 9. What is the value of x? Okay, so what is it? What do we know? We know that we're selecting out of rhesus negative, right? So only this column right here. Uh, yeah, let me see. This column right here is being chosen. Oh, yeah. And we know that the probability of choosing your blood type B is 1 over 9, right? So what does that mean? So what do we know about this then? So we have um, 2 people who have rhesus negative and blood type B out of a total of, I think it's 7 plus 2 plus 1 plus x, where we don't know what x is. And this should be equal to 1 over 9. Putting this into kind of like here's what we'll do. We'll just simplify this a bit, and you get 2 over 9, 10 plus x. Okay, and well, we know that the numerator here is 2, and that this should be equal to 1 over 9. So 1 over 9 when the numerator is equal to 2 is equal to 2 over 18, right? So that means that 10 plus x should equal to 18. And thus x is equal to 8. And that's how you solve this problem. Things got a bit messy there with my annotations, and I'm sorry for that, but let's move on to the next question. The next question states, a grove has 6 rows of birch trees and 5 rows of maple trees. Each row of birch trees has 8 trees 20 feet or taller, and 6 trees shorter than 20 feet. Each row of maple trees has 9 trees 20 feet or taller, and 7 trees shorter than 20 feet. A tree from one of these rows will be selected at random. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? Okay, so what I would suggest for these types of problems is making kind of like a table. So we have birch trees and maple trees, right? Wait, I'll remove the tree portion. And then in this side right here, we have greater than 20, and we have less than 20. Okay, so what do we know? We have 6 rows of birch trees, right? And well, before I get into that, wait. Yeah, we have 6 rows of birch trees, right? And each birch tree has 8 trees that are 20 feet or taller. So greater than 20 is 8, but we have 6 rows of birch trees, right? So times 6. That would be 48 birch then. And 6 trees that are shorter than 20 feet. So we have 6 times 6 rows, so that's equal to 36. And then for a maple, what we have is we have 5 rows of maple trees, right? And each row has 9 trees taller than 20 feet. So 9 times 5, which is 45. And we have, let's see, 7 trees shorter than 20 feet. And again, we have 5 rows. So 7 times 5 is 35, right? And we're asking what's the probability of selecting a maple tree given that our tree is 20 feet or taller. So our 20 feet or taller row in this case is this. I should have put an equal sign here too as well, but it'll be fine. And we're asking what's the probability of doing this birch tree. Sorry, not birch tree, maple tree. Right here. Maple tree. So how are we going to figure this out? So the total number of trees that are greater than 20 or greater than or equal to 20 feet is 48 plus 45. That's equal to 93 if my math is correct. Yeah, 93. And the number of maple trees is 45. So that means our answer will be 45 by 93. And of course, we can simplify it down a bit because both of these are divisible by 3. So it'd be 15 by, let's see, 31, I believe. Yeah, 31. And that would be our answer. Moving on to our next question, we have... Actually, oh yeah. So this is not a free response question. This is a multiple choice question. So we click C and move on. Moving on to the next question, again, is part 3 right here, which says, on May 10th, 2015, there are 83 million internet subscribers in Nigeria. The major internet providers are MTN, Globacom, Airtel, Etisalat, and Wisafone. I'm pretty sure I butchered the last two, but that's fine. By September 30, 2015, the number of internet subscribers in Nigeria had increased to 97 million. If an internet subscriber in Nigeria on September 30th, 2015 is selected at random, the probability that the person selected was an MTN subscriber was 0.43. If there are P million MTN subscribers in Nigeria in September 30, 2015, to what nearest integer is the value P? Okay. So what do we know? We know that in May 10, it was 83 million, right, subscribers. And in September 30, we had, 97 million. And at September 30th, the probability that was MTN is equal to 0.43. And then it's asking what is the number of subscribers? It's P million subs at September 30th. So in a way, this question, it's kind of like not all the parts of this question is needed because nothing in our answer requires the information of May 10th. We don't need this part at all. What we just need is, given that the total subscribers is 97 million, we do 97 million times 0.43. And you can use a calculator for this. Let me see if I have it with me. Yes, I do. So plugging this, we get 41.71, I believe. Yeah, and to the nearest integer. Remember, it's saying to the nearest integer. So we have to be careful when we look at the problem. What is it asking? Is it for decimal format? Is it asking for 10th place? Is it to the nearest integer? So always make sure that you know what you're looking for. And rounding that to the nearest integer, we get 42, which is in million. So given that it's P million, we can just remove this million part right here. And we have P is equal to 42. Moving on to the next question, we have the table summarizes the distribution of age and assigned groups for 90 participants in a study. One of these participants will be selected at random. What is the probability of selecting a participant from group A, given that the participant is at least 10 years of age? Okay, so, and express your answer as a decimal fraction, not as a percentage. So what do you know? We know that that we're selecting one participant, and that they're at least 10 years of age, and we're asked to find what's the probability that it's in group A. So if it's at least 10 years of age, that means we can eliminate this table right here, or this column, because it's from 0 to 9 years. So what we have is the total 30 plus 30, which is 60, right? So we have 60 total options or people that we can have. And out of those 60, we're asked to find, what is how many of them are from group A. Group A is 14 and the 10 to 19 group, and 9 from the 20 plus age group. Altogether, that leaves us with 23. So our answer would be 23 over 60. And using your decimals calculator, you can always calculate the decimal portion. But a fraction is also fine as shown here. Okay, moving on to our last question. It states that set K contains all the positive integers that are less than or equal to 160, where none of the integers are repeated. If a number is selected at random from set K, what is the probability of selecting a number that is even or less than or equal to 50? Okay, so how do we approach this problem? Well, we know that the first 50 integers are going to be a possibility. So that's 50 numbers right there. And we have 160 minus 50, which is 110 other numbers other than these 50, right? But we only want the even numbers in this, so we have to divide this by 2, and we get 55. And then you can add these up, and we get, oh, wait, it's, okay, so before I go on to this, I actually made a slight mistake here, and this is actually really important, because let me talk to you a little bit about probability. So probability is the chances of getting something or like not getting something, right? So there are several terminologies that you need to know. First is and then the second is or. There are others, but for the purposes of the SAT, this is what you need to know. For and, what you need to do, let me start with or first, since it might be a bit easier. So think of it this way. Or is, say you get, I don't know, let me see, a bag of Skittles, okay? Okay, and you have different colors, blue, green, and orange. Okay, and say you have different sizes in the Skittle, okay? Like small and large Skittles. Like say it's an assorted bag with multiple sizes. Okay, so an or would be like blue, small Skittles. No, let me do blue Skittle or green Skittle. Okay. So say you have 10 blue Skittles and another 10 green Skittles, and as well as 10 orange Skittles. Okay. So blue or green would be equal to blue Skittles, which is 10, plus green Skittles, which is another 10, which is 20, over your total Skittles, which is 30, okay? So when you have the terminology or, what you're going to be doing is adding the probabilities of the first value and then adding it to the second probability, which is, in this case, blue Skittle is the first one and green Skittle is your next one. And however, is something like, what is the probability of getting a blue Skittle and a and a small Skittle? What you mean in and is that you need to have both of these conditions to be true. Say there are in the bag of Skittles, 15 of them are small and 15 of them are large, right? So blue Skittles, you have 10 of them over a total of 30. And then for small Skittles, what you have is 15 out of 30, right? So what you need to do is multiply these probabilities. And then you're left with 1/3 times 1/2, which is 1/6. And of course, this is assuming that the small Skittles and large Skittles are evenly distributed across the colors. Um, that's what we're assuming in this situation right here. But when you have and, it has to have both possibilities, is what I'm trying to say here. So what that means is if with and, it has to be less than or equal to 50, and it has to be even. So again, you have 50 integers that are less than or equal to 50, right? And since they're positive integers, it's 1, 2, 3, 4, so on and so forth, all the way up to 50. And we need them to be even, okay? If we, well, how many of them are even? It's going to be half of them, right? So you have 2, 4, 6, 8, so on and so forth, all the way up to 50. So that would be equal to 25. So what we'll have is 25 over set k, or which is all the positive integers that are less than or equal to 160. So that's going to be 160 integers. So it'll be 25 over 160. And then we need to simplify this out by dividing both sides by 5. And we get this to be equal to, I believe, 32. And that's answer choice A. And that's how you solve this problem. Whenever you're dealing with probability, what I would suggest is try to make a table if possible. And that makes it way easier to understand. And also, make sure you understand the difference between and or. Because I nearly got confused here too. So it's really important that you look for that keyword. And that's all for today. Thank you all, and have a great day. I hope you learned something from this video.